everyone, welcome to my YouTube channel Erudispace. I am Dr. Mohanty and today we will discuss about the Carnot's theorem. While discussing the Carnot cycle, I have told you that Carnot cycle gives the maximum efficiency within given temperature limits. Carnot cycle, as you all know, is a completely reversible cycle. So that is nothing but your Carnot's theorem. The Carnot's theorem states that of all the heat engines operating between a given constant temperature source and a given constant temperature sink, none has a higher efficiency than a reversible cycle. So that is what I have told you while discussing the Carnot cycle. But now here what we will do, we will take the case of a reversible cycle as well as an irreversible cycle, and we will assume that the irreversible cycle actually gives the better efficiency compared to the reversible cycle, and when we will see that that is not practically feasible, then this should be proved. So for that, let us consider a source at temperature T1 and we have a sink at T2. And all of us know that the source and sink are reservoirs of infinite heat capacity, so that the transfer of heat from the source or the transfer of heat to the sink will not affect their temperatures. So let us consider first a irreversible heat engine. Let it be EX. It is extracting Q1x amount of heat from the source and delivering Q2x amount of heat to the sink, and it is producing Wx amount of work during the cycle. Let us consider another heat engine. This one is a reversible one, EY. This is extracting Q1y amount of heat from the source and it is delivering Q2y amount of heat to the sink and producing Wy amount of work during the cycle. And it is so arranged, the amount of heat extracted from the source is same in both the cases. You can say that Q1x is equal to Q1y is equal to Q1. Now let us assume that this engine, which is an irreversible heat engine, is giving a better efficiency compared to the reversible one. So eta x is greater than eta y. Let us assume that. So what is the efficiency? Efficiency is the ratio between the net work output to the heat supplied. Net work output is Wx and net heat supplied is Q1x. That is greater than net work output in this case is Wy and the heat supplied is Q1y. All of us know that we have taken Q1x is equal to Q1y is equal to your Q1. So this implies Wx divided by Q1 is greater than Wy by Q1. So this implies Wx is greater than Wy. And all of us know that when you are following a reversible cycle, then all the processes can be reversed. So now let us consider, as far as Ex is concerned, that is an irreversible one. So here it will extract Q1x amount of heat, will deliver Q2x amount of heat to the sink and will produce Wx amount of work. As far as the second one is concerned, here it is reversed. So now this becomes a reversed heat engine and it is actually extracting Q2y amount of heat from the sink, and this is the work that is done upon it, and then it is delivering Q1y amount of heat to the source. Now one thing you can observe, that it is actually delivering the same amount of heat which is being extracted by this engine Ex. Now next move, what we can do, we can eliminate the source and directly supply the amount of heat to this. Then what will happen? Here one of the reservoir is eliminated. You have Ex. You do have the temperature sink T2. You have the reversible. Now it is the reversed heat engine because it is reversed. So in this case, this source may be eliminated and this heat engine and this reversed heat engine put together is doing net work Wx minus Wy by interacting with a single reservoir maintained at temperature T2. So this actually violates the second law of thermodynamics, because you cannot run a heat engine by interacting with a reservoir at a single fixed temperature. So this is due to the erroneous assumption that eta x, that is the efficiency of the irreversible heat engine, is more than the efficiency of the reversible heat engine, which is eta y. So in all the cases we do have eta x less than eta y. So what we have discussed while discussing the Carnot cycle is being proved by considering this specific example. I sincerely believe that this lecture on Carnot's theorem would be extremely useful in understanding the concept of the reversible heat engine and how the efficiency is more than the efficiency of an irreversible heat engine when they operate between the same temperature limits is proved. Thank you very much for watching this video. If you have any doubt related to this, please do put questions so that I will try to answer. If you have not subscribed to my channel till now, please do subscribe and please do share this video with your friends. Thank you again for your support.